Hey you guys, this video is going to be for the Monday class that I tutor. And what we're going to talk about today is inscribed angles. We're going to cover some stuff about inscribed angles. I think we talked about that during one of our tutoring sessions. So inscribed angles, do something quick on that. We're also going to talk about multiplication and division of signed numbers. And that is in lesson 71 to 72, I believe, maybe a little bit further. Multiplication and division of signed numbers. Talk about that. Might be 73 as well. It's somewhere in the 70s, low 70s of the Saxon 8-7 book. And then finally, we're going to talk about fractions that are part of a whole. That's what we're going to talk about today really fast. And I think I might have made a mistake. This is for just confusing the Monday and Wednesday classes. This is for just to be clear, because I forgot what class meets on what day. I do know which one each class is, but this is the 8-7, the Saxon 8-7, so the younger class. But this is what we're going to talk about today. So let's start with inscribed angles. We talked about this a little bit when we met last time, so I'm just going to go over it really fast, just to clear some things up if y'all are a little bit confused. We're going to go over that really fast and then head to the other stuff. So inscribed angles. So first of all, inscribed angles. Okay. First of all, let's talk about a circle. I have a circle right here, and in the middle of the circle, I have the middle of the circle. Let's say that we took a line, we drew it out from the center of the circle to a point on the circumference of the circle, like that. Another line and drew it out like this. We can call this, just to be clear on the definitions, we can call this angle right here that was formed by these two lines. We can call this a central angle. And it makes sense because we're drawing it. This angle is between two lines that are at the center of the circle. So this angle, we'll call it angle A. Angle A is a central angle of the circle. Pretty simple. Now, what this, you can imagine this, I like to use the pie analogy. I've been using that a lot recently. What I like to imagine this sector right here as, drawing this in blue, is it's almost like part of a pie, right? And so the bigger the angle gets, the bigger A gets. If I was to rotate A out, let's say it's like the hands of a clock, if I rotated that down, so this one moved down, let's say to here, my angle A would get a lot bigger and my sector would get a lot bigger as well. So this right here is called arc length. Arc length. And it's some portion of the circle, and it's dependent on this angle A of this of two lines drawn in the beginning here. So that's just a couple of terms to knock up. But what we're going to talk about for inscribed angles is something a little bit different. But it's very important to have this central angle idea in your head, because that's something that comes really into play when we start talking about inscribed angles. Now, what is an inscribed angle? Let's get rid of this here. Inscribed angle of a circle. There we go. Let's draw this nice big circle. Inscribed angle of a circle. We still draw our center. Now let's say instead of drawing a line from the center of the circle, we draw a line from the outside of the circle, the outside circumference. We take a line from here, pull it out to here, take another line and pull it out to here. Now we have another angle, this angle right here. Call this angle B. Angle B is an inscribed angle of the circle, and you could actually draw multiple inscribed angles even from the same point. What really matters about an inscribed angle is where it hits on the other, or the points of the lines that make up the angle hit on the circumference of the circle. That's really important for later when we talk about this. Now, you might be wondering, how would I even possibly find the inscribed angle? Because if we're talking about them, obviously we're trying to find them. And so that's basically accomplished by this theory that we talked about in class a little bit. If I were to draw this central angle like we talked about a second ago, from the center to the same 2 points that the inscribed angle is at. Here, oops, here, let's use different color. Here, and here, same points. This angle right here is our central angle, call it A. Well, this theorem says, the central angle, inscribed angles theorem, I forget the name of it. The theorem that discusses inscribed angles and central angles essentially says that B, the measure of angle B, is equal to 1/2 the measure of angle A. I think that's pretty nifty, because it can be used to describe any angle in this circle that has these endpoints here that I just talked about right here. So let's just do an example really fast. I'm going to erase this. I'm going to draw another one. I'm going to start from down here. It's going to get a little bit messy, but okay. All right, now I have another angle here. Call angle B. Okay, according to this theorem, it should be it's a different angle, right? It's at a different place, so it should have a different measure than, let's call it B prime. Should have a different measure than our B angle. Well, let's look at this theorem again. Angle B, that could be anything. That could be angle. You could replace this B over here with any angle. It could be C, D, doesn't matter. It's just got to be an angle that has the exact same endpoints as a central angle. If it is, and it's angle B, so B prime fits in that case, B prime, then B prime is equal to 1/2 A. So it's actually the same. And this is interesting because any angle that we draw in this circle that fits that criteria, so let's draw another angle, goes from here, it's going to start getting messy, to here, same endpoints again. We'll call this angle C. We'll use this maroon. Well, C fits in that category too, because it's an angle that's inscribed. That means it's on the outside of a circle, and it has the same endpoints as the angle A. So it's 1/2 of A. So C, B prime, is equal to C, which is equal to 1/2 A. Okay, so B prime, C are both equal to 1/2 of A. So we talked about that. And let's do a quick example for inscribed angles. We have a circle. Oh, let's do that again. Have a circle. Let's say we have this inscribed angle that looks like this. Goes from here, here. Yeah. We want to find the angle here. We'll call it angle A. I'm going to find this angle. Now, just with that information, we couldn't find it unless we had a piece of paper and a protractor or a compass. But what we can do is notice that the other information that we have is that we have a central angle. It goes from there to there. We know the measure of the central angle. I'll give it to you. It's looks like it's about, say, 115 degrees. So if you're watching this video, we'll make 115 degrees. Watching the video, take a second to try to figure out what angle A is. I'll let y'all do that right now. Okay, so trying to figure out angle A. We know that angle A is 1/2 of a central angle called this angle C. So the central angle in this case is 115 degrees. So if we're trying to find A, we see that it matches the criterion of being an inscribed angle, so this is on the outside of the circumference of the circle. And also it matches or it fulfills the requirement that it has the same endpoints as I wrote here as the central angle, 115 degrees. So we can write down angle A is equal to 1/2 115 degrees. So doing that real quick, we know that 1/2 of 100 is 50. We know that 1/2 of 14 is 7. We know 1/2 of 1 is 0.5. So 107.5 degrees is what angle A is. Oh, I messed that up really bad, didn't I? 57.5 degrees for angle A. Here we go. So that again. 57.5 degrees for angle A. It's not too bad. And you might get a question that asks you, given angle A here, find a central angle here. And that's just the reverse process. So if I was going to do that and I erased this, and I said this is angle C, and I erased this, and I said this is angle, what's that? 60, which that's pretty small for 60, but I could say, okay, well, I have my formula, A equals 1/2 C. I could take C, I want to find C, so I can multiply both sides by 2, and I can get C is equal to 2A. Then the math becomes really easy because I just plug in A for my inscribed angle, and I get 2 times 60, which is 120 degrees. So angle C in this case, even though this picture is inaccurate, this would be 120 degrees. That's how you could go both ways, and that's a question that you might see in problems. So that's inscribed angles. We talked about that. I just wanted to clear some stuff up. Let's talk really briefly about multiplying and dividing signed numbers. So we'll say multiplying and dividing signed numbers. Don't want to write all of that out, so let's just do it like that. So let's talk about multiplying positive numbers. So if I have a positive number, 5 times 4, that's just saying 5 4s or 4 5s. So we know that 5 plus 5 plus 5 is 5. That's 4 5s plus 5 plus 5. 5 is 20. Hopefully you all know that. And that can go both ways. You can do 5 4s. Also equal to 20. 4 times 5, though, 4 multiplied by 5 is 20. That's doing that. And dividing is the same deal. 10 divided by 2. How many 2's are in 10? It's 5 because 2 plus 2 plus 2 plus 2 plus 2, that's 5 2's equals 10. So how many 2's are in 10 is, oh, I messed that up. Yeah, how many 2's are in 10? 5 2's is the answer. So that's multiplying and dividing. However, if we have multiplying and dividing signed numbers are, if I have 10, we just assume 10 is, a positive number just because of the notation, but actually a positive 10. It's just a regular 10. But negative numbers, we actually notate it with a negative 10. And what a negative number is, just briefly, is a number, if we have a number line like this with, this is 0, and this is 1, 2, 3, 1, 2, 3, 4, going that way up into infinity, we also have a corresponding inverse number line of -1, -2, -3, -4. So dealing with negative numbers is a little bit kind of the opposite. So if we have a -4 times a 5, that's 5 -4s. -4 plus -4 plus -4, 5 times plus -4 plus -4, and that would be -20. Because if you think about it, if you're adding these -4s together, you're going -4 directions this way on the number line. 1, 2, 3, 4. and then 4 more, 4 more, and 4 more, 4 more. Eventually that'll get you to negative 20. Just like going to the right 4 times or 5 times will get you to positive 20 starting at 0. So we start for these. Going to the right 5 times gets you to positive 20. That going left 4 times or 5 times will get you to negative 20. Same kind of thing for division. If I have negative 10 divided by 2, that's asking how many 2's, or better yet, if I were to take negative 10 and what's half of negative 10? That's essentially what that's asking. So if I have negative 10, so 1, 2, 3, 4, 7, 8, 9, 10, like that. There's negative 10. What's half of that? What's half the distance from 0 to negative 10? That's negative 5, because if I go 1, 2, 5, this, that's halfway between, because I can go 5 more this way to get to negative 10. That's how you do that. Now, when it gets interesting is when we have 2 negative numbers. Multiplying 2 negative numbers. Let's look at that real quick. Negative 1 times negative 2. What actually happens here is the negative signs cancel. So negative 1 times negative 2 isn't negative 2, it just becomes 2. Negative 1 times negative 10 isn't negative 10, it's 10. Negative 4 times negative 5 is positive 20. That makes sense because you think about what we were doing before. We're multiplying negative 4 by 5. We were going 5 times negative 4 in the left direction. But now we're doing the opposite of that. We're still having negative 4, but we're going 5 times the opposite of left, so it's right 5 times. So you can think about it like that. It's the opposite of what you do if you're multiplying this going left. But the opposite of that, if you flip-flop that, obviously going to the right on the number line, you're going negative 4, multiplying that by negative 5, and that will actually get you to the right. So that'll get you to positive 20. Well, that will get you negative 20. And the same kind of thing applies when you're dividing. If you have negative 10 divided by negative 2, it doesn't become negative 5, it's regular 5. And so if you think about that, the line 0, 1, 2, 3, 4, 5, 6, 8, 10. We have negative 10. And you can just think of the negative 2 as flipping the number line around. We're flipping it around all the way over to the right side. Now I don't have enough space to write 10, but there's 10 right there. I don't know if there actually are, but there's 10. So flipping it around and going half. So all the negative 2 does is it takes what we normally would have as a negative 5, as a negative 5 for answer, and flips it around to a positive 5. That's the best way I can think of to describe it. But the rule of thumb that you want to use is multiplying. You have a couple cases. Multiplying a number, multiplying. I just make a little table here. Multiplying 2 positive numbers, positive and negative, or 2 negatives. Same goes for dividing. What do we get? Our result is positive, negative, positive. So if we multiply or divide 2 positive numbers together, we get a positive number. If we multiply or divide a positive and a negative number together, so that's 2. So that's a positive number and a negative number, or a negative number and a positive number in any order. Get a negative number, and the same thing goes for the negative. Multiply negative by negative, you will get a positive. So there's one thing that you can use that makes this more useful. And this is kind of an extension of the basic idea of multiplication and division by signed numbers. But let's say we were adding or multiplying a couple numbers together. So 2 times 5 times 4 times 3. Now, there's nothing that would make you think that this would be negative because they're all positive. And if you did this, you would just automatically assume that the number should be positive. So that's 4 times 3 is 12, and 2 times 5 is 10, so that's 120. Positive 120. Now, what if we did this? 2 times minus 5 times minus 4 times minus 3. Well, then it becomes a little bit more weird, because if we multiply these two together, you can do these in any order, but this is the order I'm choosing to do it in. Here's one easy way to break it down. And then after this, I'll come up with a general rule. If we have 2 times negative 5, we learned that multiplying a positive number and a negative number together actually gets you a negative number, so this becomes negative 10. And then multiplying 2 negative numbers together gets you a positive number. So negative 4 times negative 3 is a negative 12, positive 12. And then you can do the same process again and say negative 10 times 12 is a negative number, since we have a negative times a positive. So it becomes a negative 120. Now, the general rule of thumb here is when you have mixed signs, multiplication of mixed signs, we can figure out, let's say we have something really complicated, like 2 times minus 1/2 times 1 times 5 times 10 times negative 21 times positive 20 or negative 22 times positive 23. Right, we want to figure out if this is plus or minus. Well, one way we can do is we could break it up. Say, oh, well, if this is going to be negative, this is going to be positive, the 10 times negative 21 is going to be negative, and negative 22 times 23 is going to be negative as well. We could break it up like that. That's one possible way to do it. That takes a long time. If you notice a pattern here, one pattern, and this is the really important pattern, hopefully you picked up one, is that if you have an even number of negatives, they'll cancel out with each other, because then that makes sense, because if you have 2 positive or 2 negatives, it becomes a positive, so that's a factor of 2. And so if you have an even number, which is even numbers are just numbers that can be divided by 2, then all the negatives will cancel out. So we can count our negatives. There's 1, 2, there's 3. So there's 3 negative numbers. So actually, these will all represent or all go together and make a negative number. That makes sense. We'll have a negative times a negative, which will be a positive, and then a positive times a negative, which will result in a negative. So these 3 numbers multiplied together, remember, you can multiply them in any order since of the associative property of multiplication. You can multiply 2 times 1, 2 times negative 2. It doesn't matter what order you do it in. So you can multiply these guys together, and you will get a negative number. And then all these positive numbers will multiply together and get a positive number. Let's put square from positive numbers. And then in the end, you'll end up having some number that's negative from these 3 guys, and some number that's positive, the other guys. And then, of course, you'll end up with a negative number. So the positive numbers all will stay the same. So it's really just about the negative numbers. If there's an even number of negative numbers, then it'll be positive. Positive times positive is positive. However, if there's an odd number of negative numbers, then that will be negative, and you'll end up with a case like this. That's an important fact of, you might get something where they don't actually ask for the answer to this problem, but they want to know if it's positive or negative. And all you have to do for that is just count up the negatives, and then if there's an even number of them, they'll all cancel out and become positives, or become a positive number. But if there's a negative or an odd number of them, they will not cancel out. You'll have 1 remaining. You'll end up with 1 positive times 1 negative in that group, and the entire group will become negative. And then you'll multiply everything else together, and you'll get a negative number. And so that's one easy way to find the sign of an answer. There's probably more on that. If you have questions, bring it up when we're talking. But finally, we're going to talk about one last thing, and that is fractions of a whole. We're going to talk about this really fast. So let's say I have a fraction, 1/5, and I want to, that's not, 1/5 is fine. I say 1/5 of a certain whole. So 1/5 of, 10 people is, I shouldn't say the final number, but let's say I have 1/5 of a certain whole that I'm not going to say. 1/5 of, I have this whole of something. It's people, it's beans, it's beads, marbles, doesn't matter. Some group and I have 1/5 of that, and I just know what 1/5 is. That's what the information is given to me, is 1/5 is 2. Now I want to know the entire whole. What would the whole be? Well, one way to think about this is the whole would be 5 of 5. Right, so what would 5 of 5 be? That would be 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, 5 times, to get 5/5. And if I know that 1/5 is 2, I can multiply this by, remember, I can multiply both sides by the same thing, by 5. I can multiply this by 5. I get 5 over 5, which is 1. That's an entire whole, is equal to 10. So now I know that this whole thing right here is 10 because 1/5 of it is 2. So that's one way to think about it. And that's what we'll use as a baseline kind of thing. Now let's say I have a more complicated question. I have a whole of 24 things. 24 people, 24 dogs, 24 pets. And all I know is that 3/8 of that group is, let's say that 3/8 of this group is, let me think about this for a second, 9. I shouldn't have said 24. But let's just assume that you didn't see 24. You just know that there's some group out there that could possibly be 24, but just a group. I know that 3/8 of this group, let's pretend that this is 3/8 here, made up of 9 things. I want to find out the entire group. How do I do that? Well, first thing you can do is you want to find out how much 1/8 is. So then you can multiply the 1/8 by 8 to get your final answer. So if I divide both sides by 3, so that's kind of multiplying both sides by 1/3. Let's do this here. If I have 3/8 is equal to 9, I'm going to get this down to 1/8 right here. Because if I have 1/8, then it's easy math. If I have 1/8, I can multiply by 8 and get 8/8, which is a whole. So then it becomes easy. But if I have 3, then I can't multiply 3 by anything but 8/3. That could also work. But let's just do it this way because this is a good way to visualize it. So if I have 3/8, and something you can do in your head, if I divide both sides by 3, and this is actually what we're doing, multiplying by 8/3, but that's a little bit abstract. This is actually kind of figuring out what's going on behind the scenes. And then maybe when you get more comfortable with it, you can do it that way. But we're trying to get this side over here to 1 because that's a whole. That makes sense. We're trying to get this side to 1. Since they're equal, we can do equivalent things on both sides. So if we multiply this side by 1/3, the 3's cancel. We get 1/8, and 3 divided by, or 9 times 1/3 is 3. So we know that 1/8 of this thing is 3. And then we can multiply both sides by 8. This will become 1 because 8 times 1/8 is 1. And 8 times 3 is 24. And the entire whole, obviously, this is a fraction of a whole. So 3/8 times something is equal to 9. So this is actually a false statement. If you just saw 3/8 is equal to 9, you would be crazy if you thought that was true. But it's really 3/8 of an entire whole of some number x is equal to 9. And so the way you'd solve that, if you had this question, I'm trying to give it visualization method. But if we had 3/8 times this whole is equal to 9, the way to solve this to get x by itself is to multiply both sides by 8/3, and that will cancel out the fraction. This fraction will cancel out, become 1, and 8 will be equal to 9 times 8/3, which is, this will cancel with this, so that becomes 1. And this is 3, so 3 times 8, which is 24, which is what we just did. But the idea that I'm trying to, and this is something that you would do you'll eventually do in your head, is if you have something that's really big, like let's say 3 216ths of, something is, this is 3 216ths of something. We're not saying that, but of something. So that's times, remember, of is actually a word that we use in English for times, multiplication. 3 216ths of something is, we'll do 15. We want to figure out what the entire whole is. What we can do is we can say, oh, well, in your head, you're thinking, okay, 3 216ths is 15. And so we want to find out the of something, because this is technically multiplied by x. 200, this right here is multiplied by x because it's 3/16 of something, but this is just what you're thinking in your head. 3/16, 3 of 3 2/16 is equal to 15. Well, you can divide 15 by 3, that gets you 5, and then 5 times 216. That's a tough one to do in your head, but if you know that 5 times 200 is 1,000, and 5 times 16 is 80, then you can get 1,080, and then it's not bad. Then you know the entire whole, the entire 216 is 1,080, and then that's not so bad to work with. So that's what we have. That's the general process of it. But if you're thinking of it and you really want to write it down, and they have a question, let's say 3/8 of a whole, or let's not do 3/8, 5/16 of a whole, you can just write down what they say. So we have 5/16 of, well, if you're writing this out for a problem, 5/16 of is multiplication. So of, we use this dot. We'll use a whole for W, of a whole. If they say 5/16 of a whole is equal to 125. Well, then you can do the math yourself, and you want to isolate W. That's a whole. You want to find out what the whole is. So you can multiply both sides by 16 over 5. The 5 will cancel with the 5, the 16 will cancel with the 16. And you got to do the same to both sides for the equality. So 16 over 5. And then you can multiply 5 divided by 125. We know that 5 times 20 is 100, and 5 times 5 is 25. So that's 25. So we have 25 times 16 is the whole. Do that on a calculator because I don't want to do that in my head. 16 times 25 is 400. That actually worked out really nicely. So we know that the whole is 400. That's an easy way to do it. But if you're doing it in your head, you could do what I was talking about, where you would divide down to get down to 1 over 16, then multiply by 16 again. And that would be tough to do, but that's just one way to think about it. This is the correct way to do it for math, writing on a word problem. But that's what I have for parts of a whole for fractions. If you have any questions, let me know on email or next time we talk, and I can clear up stuff for you. But for now, that's all I got. Thank you guys for listening.